All right, so we're getting into factoring. That's 13.1 for you guys. Greatest common factor, or in other words, GCF. So what does it mean to factor? If we had this expression, x times 2x plus 5, first thing we would do is distribute the x. If you want to, distribute, FOIL it out, and simplify the expression. And once we do that, that will give us 2x squared plus 5x. So factoring is actually taking it back and undoing the multiplication process. All right. So that's what factoring is for us, is undoing the multiplication process. So in other words, I will pull the x out of both of these terms to the front. And that x is considered my greatest common factor, my GCF. So I go from having this expression and taking it back to x times 2x plus 5.
How'd you know that use x as the GCF?
Well, that's what we're talking about, what is common between the two terms.
Oh, okay.
Yeah. So when you talk about factoring, they're going to say, eventually they're going to say factor completely. So you're asking yourself, what is the common term or the common thing or the common element that I could pull out of each term? So, of course, I couldn't pull 2 out of both numbers. I couldn't pull 5 out of both numbers. But it's an x that's in both that I can pull out and bring to the front. All right. But the more we do it, the more you'll see it. And the more we go through the practice, you'll see how you'll be able to determine that. All right. So first exercise, identify the GCF, the greatest common factor. They give us 40, 52, and 32. And so what I say is, well, we can take each number and break them down to the prime factorization. So in other words, break them down to prime numbers. All right. So you start off with just 2 numbers. So when you look at 40, what 2 numbers will multiply together to give you 40? And we see that that is 4 times 10. Or you could have did 2 times 20. It doesn't matter which 2 numbers you use, as long as those 2 numbers break down to give you, or multiply back to give you 40. Then you break down the 4, get 2 times 2. Break down the 10 to get 2 times 5. So you break down your numbers till you can't break them down anymore. You break it down to prime numbers. Same thing with the 52. What 2 numbers will multiply together to give me 52? 2 times 26. Or you could have did 4 times 13. It doesn't matter. You'll keep breaking them down until you get the prime numbers. 26 breaks down to 2 times 13. Then with 32, I decided to use 4 times 8. Broke down to 4 to 2 times 2. Broke down to 8 to 2 times 4. And I still had to break down this 4 to 2 times 2. So you break them down all the way to prime numbers. In other words, until they cannot be broken down any further. So before we go any further, make sure we're okay with that. Give you guys a chance to write that down. Okay. All right. Trying to put my boxes back up. All right. Any problems so far? All right. So here, all I did was list the numbers as their prime factorization. So 40 was 2 times 2 times 2 times 5. 52, 2 times 2 times 13. 32 was 2 times 2 times 2 times 2 times 2. And then right here we see that I say that the GCF will be all numbers or variables that each have in common. So when we look at our 3 numbers, they had 2 2s that were in common. So our GCF is 2 times 2, which is 4. So 4 is the largest number or largest term that I can pull out of all three numbers.
How come we didn't use the rest of the twos?
Well, it's all about what they have in common. Remember, it's the greatest common factor. So when you look at what they have in common, they have two twos that are in common with all three. You see what I mean? So this represents 1, 2. They have 1, 2 that's in common, and then this represents the second 2 that they have in common. All right. So if they had a 7 that was in common with each, then that would have been 2 times 2 times 7. You would have to include that 7. Did that answer your question? I want to make sure I got you.
Yes.
Okay, cool. All right, everybody good before I scroll up to do another one? All right. So this time we're looking at 28mn, 24m cubed n. So I took the 28 and 24 and broke them up to prime numbers like I did the last three numbers. 28 is 4 times 7. Then 4 is 2 times 2. 24 I did 4 times 6. And broke up the 4, 2 times 2, 6, 2 times 3. All right, so you have 2 times 2 times 7 times m times n for 28mn. Then for 24m cubed n, you have 2 times 2 times 2 times 3. And then we have 3 m's and 1 n. So that's what's going on right here.
So we just subtract the variables?
Say it again.
So we just subtract the variables?
Well, it's all about asking yourself, what do these two numbers or these two terms have in common? So we see that they have two 2's that are in common, 1 m and 1 n. And so that's how I got that right there. They have two 2's, 1 m and 1 n that they are that's in common between the two terms. And that's what I did here with the box. It's just showing that we have the connection between this 2, this 2, this m, and then this n. And then multiply those together. That'll give you 4mn as your GCF. So remember, you're always asking yourself, what do these terms have in common? All right. We'll do some more of that in a second. But any questions on anything I've written so far? All right. An expression is prime when it cannot be factored at all. In other words, there's nothing in common. There's nothing you can do with it as far as breaking it down. All right, so let me reset this stuff. All right, so it says factor out the GCF if possible. So always remember, if possible, they give that option for prime to be the case or to be the answer. So 12r cubed minus 18r squared minus 30r is our original expression. When you look at all three numbers, 12 is 2 times 6, 18 is 3 times 6, 30 is 5 times 6. So we know that we can pull 6 out of each one of those numbers. Then when we look at how many r's we have in each, notice here the most that I have is 1 r in that last term. So I can't pull out more than what I see in all of the terms, right? So I have 3 r's here, 2 r's here, and 1 r here. So the most I can pull out of all three is just the 1 r. So that's how we got the GCF being 6r. So it was a 6 in each one of those numbers, 2 times 6, 3 times 6, 5 times 6. And at the most I can pull out of each term is 1 r. I can't get 3 r's out of that 30 r because there, like I said, there's only 1 r. Okay. So I hope that makes sense. If not, feel free to let me know.
Quick question. I'm sorry. So it's 6 because that's the common factor for all three of the numbers, right?
Yep.
Okay, got it. All
right. Yep. So when we talk about that GCF, you can only pull out what is common from each number. Yep.
Okay.
Same thing as if I didn't have an R right here for 30, then all I could pull out is 6 because there's not an R in each term. Yep. So let me do this. So when I say my GCF is 6R, that means I want to pull and put 6R out front. So now you want to talk about what's left after I pull 6R from the 12R cubed. So if you take 6, we already talked about right here, if I took the 6 out, you'll just be left with 2. So it's going to be 2. And if I take one of the R's out, I'll be left with R squared. Minus, if I take, remember I have 2 times 6 right here for 12. If I take that 6 away from the 12, then I'm left with just the 2. Because remember we talk about in terms of multiplication.
I got it, because 6 times 2 is 12, right? Okay.
And see, when we multiply this back out, I should get what I originally had.
Which would have been 12R.
Right, exactly.
Okay.
And then we keep that same thought process when we go to the 18. If I took 6 out of it, then that's going to leave me with 3. And then looking at R squared, if I take one of the R's out, then I'm left with just R. And then for the 30, that'll be 5. And if I take this one R, then I don't have an R. And so this would be what's left in the parentheses, 2R squared minus 3R minus 5. And when it comes to factoring, you can always check your answer because when you multiply this back out, it should give you what you originally had. And that's what I was saying here.
Okay, so we don't count that R and the 5 because we would multiply that times the 6, and the 6 already has the R attached to it.
Yep.
Okay.
Yep. And like I said, when you guys, it's always good, especially when you first start factoring, to check your answer because let's say if you decide to leave this R here, when you do 6R times 5R, that should give you 30R squared, which is not what you had originally. And so that will prompt you to go back and say, hey, somewhere I went wrong or whatever. Yep. Once you guys become pros at it, you won't need to check and all that. But you know, initially it might be good for you to check behind yourself. All right, so next one we have 12a b to the fifth c cubed. Somebody say something?
Me.
Uh-huh.
We took the R from the 30R, so why wouldn't it be just 5 right there?
Oh yeah, I left that. I put it there just as an example to what Miss Christina was asking, but then I didn't take it back
Okay.
off. Yeah. So that was my fault. Thanks for letting me know, because I would have left it there, and some people might have kept it this way. All right. Any other questions before we go to the next one? All right, so now we're looking at this one. 12ab to the fifth c cubed plus 16a to the fourth c squared. Matter of fact, let's see if you guys can give you a chance to process it, see if you can find the GCF before I just say what it is. I kind of give you a hint in the red, but it's not hinting at the letters. Give you a second. All right, so we know as far as the numbers are concerned, we have 12 and 16. Like I said, I gave you a little bit of hint right here. We have 4 times 3 is 12. 4 times 4 is 16. So we know 4 is in common.
And 2s.
The
4s and the 2s would be the ones who would count?
Now, when you break them down, it depends on how you broke them down. Now, if you break them all the way down to prime numbers, ultimately what you would have is 2 times 2 times 3.
Yeah, right.
And this would be 2 times 2 times 2 times 2. Right. And what would end up happening is that 2 times 2 is what would be in common, which would be 4.
Oh, okay, got it.
So all I did was shorten up the process right here, because I already knew that 4 times 3 and 4 times 4. Now, when you're not familiar with your numbers, that's when you have to lean on these processes right here. You know what I mean? But if they're more familiar numbers like 16 and 12, then you can go ahead and break it down like 4 times 3, 4 times 2 type stuff. Yeah. But once again, unfamiliar numbers, you always can lean on this process to figure out what the GCFs are. So we could have did that, like I said, you could have did that with the 16 and the 12. All right. And then notice we have, say it again.
I'm just trying to check and make sure. I think I missed something. How do you, when you got the 4, we got the 4 as the greatest common factor. So do we count the pairs that we had?
Well, you said the pairs, what you mean? The 2 2s?
Like the 2 2s, yeah.
Well, no, the 2 times 2 is the 4.
Oh, okay. That's where I was getting confused. Okay. All right.
Yeah. So you're either doing it this way or you're doing it this way. But either way, you should be getting 4.
Yes, I got the 4. I just didn't know how.
All right. So you good at it?
Yes.
Okay. All right, cool. So now we're looking at A's. We have an A right here and 4 A's right here. So at the most we can pull out is the 1A. Now notice there is not a B in both terms, so we can't use B as the greatest common factor, as a part of my greatest common factor. And then we have 3 C's here, 2 C's here. So the most you can pull out is the 2 C's. And so that's why my GCF is 4AC squared.
AC squared. Okay, so when you can't pull out the number, you just leave it there and don't do anything with it.
Right. All right, so now we know what our GCF is. We know what's going to be on the outside. Any questions before we talk about what's going to be on the inside of the parentheses? All right, so what's on the inside of the parentheses is always about what's left after you took out the 4AC squared. So when it comes to 4 times 3 or the 12, you're left with just 3.
I have a question. Oh, you have 3 squared and 2 squared. So what do we do with the squares, the two different squared numbers?
Hold on, you said 3 squared?
You see on the C, you got 3 to the third and 3 to the second. So how would we do that part?
Hold on, where you see 3 to the second at?
Over here at the top, 2c squared right here, and it's 3 to the third.
Hold on.
In this example right here, 12ab, yes, that and 2 squared. I mean,
oh,
C
that's, I thought you said 3 to the third. That's C to the third, right?
Yeah, I said C. Maybe you couldn't understand.
Okay. Yeah. Well, we about to do that now.
Oh, okay.
Yeah. See, what's left goes in the parentheses. So you have to analyze. We took 4ac squared out of both of these numbers, out of this number and out of this number, or this term, right? So now what's left goes in your parentheses. Just like going back here. We took 6r out of 12r cubed, and what was left from that 6r, extracting 6r, was 2r squared. So that's what we have to analyze now, what is left. And c cubed is a part of what was left.
So we're not even doing anything else with that, with the c that's squared. We're going to work with the c cubed.
Well, that's a part of what's left. So let's do this. So looking at the 12, if I took 4 from the 12, I'm left with just that 3, right?
Yes.
So now this a represents what I took out of that 12ab5c cubed. So if I took a out, then there's not going to be an a here.
Right. But it'll be a b, right?
Say again?
It'll be a b, right?
So next would be b to the 5th, right? So now how many c's did I take out of this term?
You already took 2, so it leaves 1 left?
Yep.
Oh, okay. All right.
And that's it. Yep.
Okay.
So remember when you multiply this back out, or multiply it back into the parentheses, c squared times c to the first power is going to give me my c cubed back.
Okay.
All right, and then we do the same thing for the 16, a to the 4th c squared. There's 4 that's left. We took out one of the a's, which is a cubed. That means a cubed, or 3 a's would be left. And we took both c's out, so there's nothing to write.
Okay. Ty, would it take me to stop calling people talking about a tornado drill in the middle of the class? We can't even get to campus.
Oh, that's what it was. I thought that was TCC.
Stop their game.
I was like, that number, that's an 822 number. I was like, wow, they better leave a message.
They play too much. Talk about a tornado drill.
That's funny. We sure is like, see, I'm in here trying to explain this stuff to you. They vibrate my phone and stuff. All right, so let's do this. Matter of fact, same color scheme. All right, so this next one, they say factor out a -1 from the polynomial. So they already telling you they don't want you to do anything else but factor out that -1. All right. So you pull a negative from each term. That just means that every term that's in the parentheses will now have an opposite sign than what they originally had. So that's -5t squared. That means it's going to be a positive 5t squared minus 3t minus 4. And that's all they want you to do, because if you were to distribute this negative into the parentheses, it give you what you originally had.
-4. A question.
Mm-hmm.
So the sign that starts the equation is the one we go with?
What are you talking about? This one right here?
Yeah, say if it was just 5t, would it always have a negative sign?
No, well, it says factor out the negative, so that's why this is right here.
Oh, okay. So if
Mm.
would it ever tell you to find a positive, or would that be the only kind of question that would have that?
Yep, that's the only kind that we get.
Okay.
So if let's say if it wasn't -5, then that means there had to have been a negative here. You know, because every sign has to be opposite of what you originally had.
Got it. Okay.
Mm-hmm. Oh, well, I did it right here, so I'm gonna redo this one. So same exercise, but we have 7x to the 5th minus 8x cubed plus 3x squared minus 9. And they want us to factor out the negative. So once again, when they tell you to do that, they're not asking you to do anything else but that. So you can go ahead and put the negative out front. And once each one of your signs should be different than what it originally had. So I have a positive 7x to the 5th. That would be negative 7x to the 5th plus 8x cubed minus 3x squared plus 9. Any questions before we go to the next?
No, we don't ever change the sign. Wait, how do I? I'm missing something. Oh, never mind. I said it. Sorry.
Not a problem. All right. Got another GCF. So we have 9a to the 4th b minus 18a to the 5th b plus 27a to the 6th b. You want to factor out the GCF. So notice we have 9 that's in common with all three terms. 18 is 9 times 2. 27 is 9 times 3, so it's 9 that's in common with all three. And when you look at the four A's, we have 4 A's in the first term, 5 A's in the second term, 6 A's in the third term. So we can pull out at the most 4 A's from each. And then there's a B in each term that we can factor out. So our GCF is going to be 9a to the 4th b. Make sure we're all right.
8 to the 4th b.
We have 4 A's here, 5 A's here, 6 A's here.
So why you don't count all of them?
Well, you only can pull out what's in common with each. So if I have 4 A's here in the first term, but 5 in the next and 6 in the next one, the most I can pull out of each is the 4 A's. Like I can't pull 6 A's out of this because there's only 4 of them there.
Oh, I got it. Okay. All right. So what do we do with that? What's left over is what goes in the parentheses.
Yep.
Okay, got it. All right.
All right. So notice that this whole term is our GCF. And don't forget that there still has to be something that's represented for that term, and it would be 1. So in other words, when I multiply 9a to the 4th times b to that 1, I will get this term back. So you always have to have something there to represent that whole GCF that you factored out. So
within the parentheses?
Yeah, in the parentheses, right. A lot of times people will forget that 1. But remember, if I have 3 terms here, then I need 3 terms here.
Okay.
So that 1 is going to represent that term in the parentheses. All right. So 18, a to the 5th b. The 18, I'm factored out 9, so I'm left with 2, a to the 4th. So that means I'm going to leave 1a, and then I took that b, so nothing else is left.
You have to use the 1?
This one right here?
Yeah, that one.
Yep. Because remember, when you multiply back out what you factored, there has to be something there in order for you to get this term. You know, if you were to not put anything right there, there's nothing to multiply right here too, and you would never get this term right here.
So we can basically think of the 1 as being a placeholder.
You can't look at it that way. Yep.
Okay.
Now, let me just go ahead. All right. And then the last one you're left with is 3, and we took out 4 A's, so that'd be 2 A's left. And that B, there's only 1 B, so that 1 B is represented right here in your GCF.
So we don't put the B, include the B in the equation because we already used it with the 9?
Right. Because remember, once again, when you fold this back out, that B is going to be a part of your multiplication process, and it'll show up at the end.
Okay.
All right. Questions before we go to the next one?
I'm trying to figure out how we get the, I know he explained it, but I'm not catching it. How we still have the A's to the square.
Well, we took 4 A's from this term.
Okay.
But it had 5.
So that left 1 over.
So it left 1, right. And then here we took 4 A's from this one.
And it left 2. Okay.
Left 2. Yep.
So always remember to start from the original. I got to remember that.
Yep, that GCF right here. Yep.
Okay.
So that's what you took out or extracted out of each term. Then you're asking yourself what is left. And what is left is what goes in the parentheses.
Got it. Okay. I'm struggling trying to figure out where it come from, but I got it. I understand that now.
Yeah, it's not a problem. You know, if you haven't seen it in a while, or haven't seen it ever, you know, you just got to get used to it, used to the process. All right, next one, 15y cubed plus 12y to the 4th. So you see here, 15 is 3 times 5. 12 is 3 times 4. So we know we have 3 that's in common with each. And that's right here, so I guess I didn't have to erase it. And then we see we have 3 y's in that first term and 4 y's in the second term. So the most you can pull out of each term is the 3 y's, y cubed.
Oh, yeah. So then you would get, try to figure this out. Yeah, 5.
So now that we've established our GCF, you ask yourself, once I pull or extract the GCF out of each term, what is left from each term? So we know out of 15, if I pull 3 out, I'm left with 5.
Plus 4.
But I also extracted y cubed, and all we had was y cubed. So 5 is all that will be in that first term. Second term, if I pull the 3 out, I'm left with 4. And I took out 3 of the y's, but I had 4 originally. So I'm left with 1 y. All right, make sure we're okay. And once again, doing these may take a little time to get used to, but once you get the process down, you'll be good. All right, this time, and this next one, they give us -3x squared plus 6x minus 33, and they tell us to factor out a -3. So you don't have to guess on what they want you to factor out. They actually tell us, factor out -3. Here's my book there, go. All right. So if you pull the -3 out, and what's left is going to be x squared. We're looking at this first term, taking -3 from that, be x squared minus 2x plus 11. So don't forget, this has to multiply to give you back this expression. So it has to make sense. Huh?
I said, okay, because I sure was about to ask you, well, what you do? No, I got it. Okay.
Because remember, we talked about when we pull out that -1, that you pull a negative out, each one of these symbols or each one of those signs have to be different than what you originally had. Right. So that's why this, say again?
It said it goes to the opposite, right?
Mm-hmm. Exactly. Okay. So that's why our first term now is positive, second one is negative, and then our last one is now positive in comparison to what we originally had.
And you basically remember to use the multiplication function.
Mm-hmm.
Could you explain why'd you take the 3 out?
Because they told us to, right here.
Oh, I'm tripping. Okay.
No, you good.
Don't feel bad. I say the same thing.
Yep. Outside of that, you would, analyze and all the stuff like that. Now, let's say they didn't tell us to and they just said factor. Then you would look at all three and say, okay, what do they have in common? And it would have been 3. But the reason why I already knew is because they told us to in this case. Yeah. And, if you were to break it down like we did the other ones, 3 is right here. And then this is 2 times 3, and this is 3 times 11. So we would have saw that 3 was in common with each, if we wanted to do it that way. I guess I could have kept that up there. All right. So let's look at this next one. They give us 2w x plus 3 minus 5 times x plus 3. And they want us to factor out the GCF. So if you notice what they have in common is this expression of x plus 3. All right. So what we're going to do is, I didn't need to do that. Put that back. We're going to take the x plus 3 just like we did, just like we did this 3. We pulled the 3 to the front. We're going to take the x plus 3, bring that out front. And then what is left is the 2w minus 5. And we put that in the other parentheses. Questions on that? Make sure we're all right. And then for the next one, we do the exact same thing. If we have 6 times x squared plus 4 plus y times x squared plus 4. We see that x squared plus 4 is what they have in common. So we bring the x squared plus 4 to the front. And what's left is the 6 plus y. Make sure we are all right. All right, any problems? All right, so this leads us into factoring by grouping, which is the last thing from this section. So whenever you're factoring by grouping, this method that we're going to use when you have 4 or more terms. All right, so here's our first expression that we'll try this on. 3ax plus 12a plus 2bx plus 8b. So what we're going to do is group together the first 2 terms and the second 2 terms. We're going to factor out a GCF out of each one and then see if this scenario is created. What we just finished doing, this right here. And if so, we'll keep going until we finish. If not, then you may have to go and rearrange your terms. I don't think you guys will get that in this class. But let's say if you're doing it in another class or whatever, you get into calculus and you do it and you don't get what you desire, then you can go back, rearrange your terms and try to process again. Like I said, I don't believe you guys are going to get that issue. Once you group together first 2 and second 2, should be okay. All right, so that's what I did right here. Group together the first 2 terms and the second 2 terms.
Do you have to do it like that? What? I'm not.
Say it again.
Do you have to do it like that?
What else you want to do?
So when it has a positive or a negative sign, that's what separates the equations.
That's what separates your terms.
Mm-hmm. I mean the terms itself. Mm-hmm. And then you would start breaking it down from there.
Mm-hmm. Okay. Yeah. So we have 4 terms here. Yeah.
Okay. How would you know which order to put them in?
Well, this is the order that was given.
So just keep them in the same order?
Mm-hmm. Yeah. Like I said, if you were doing it, I don't believe your book would make you switch around stuff. I don't think you guys are going to get that complexity of problems, but you can move around your terms. It's just that I don't think it's necessary for what you guys will get. So you can just leave them the way they are, group together the first 2, group together the second 2, and then factor out the GCF from each.
Okay, so the GCF for this would be, you got to break the numbers down, don't you? Find a common denominator.
Common factor.
Mm-hmm. I mean, a common factor.
Mm-hmm. So when you look at this one,
3 times 4 is 12. Then you break down the 4 to 2.
3a. Okay. And then this one has 2b, that's in common.
Yeah, 2 times 2 is 4, right? I mean, that's 4, and then you break down the 4. Okay.
Mm-hmm. So now we notice x plus 4 is in common with each. That has to be the case in order for you to finish off the problem. If that is not the case, then you need to go, that's when you know you need to go back and rearrange terms. But x plus 4 is in common with each. So we're going to bring the x plus 4 out front. Excuse me. And we're left with 3a plus b in the other parentheses. Now here's somebody that asked me a question about the organization of your terms. Notice as long as x plus 4 is inside the first parentheses or the other parentheses, and 3a and 2b are in the next parentheses, then it's still going to be the same thing. But what you couldn't do is have 4 plus 2b and x plus 3a. That would be something totally different. And if you did everything correctly, you shouldn't get that anyway. And then if you had, let's see, 3a, 2b, x plus 4, that's the same thing as well. Like I said, as long as what's in the two parentheses are the same, you're okay.
Okay, so all 4 of those last answers are correct, Professor?
Yeah, so talking about this one, and this one. Mm-hmm. Okay. Yep, you could write it either way.
We can't leave it as just 3a and then parentheses x plus 4 plus 2b x plus 4?
This one right here?
Yeah.
No, you got to go this next step.
I'm a little confused.
So it has to be one of these 3. Mm-hmm. All right. Yep, you said, Miss Christina, you said you had a
3a plus. Why you have the equal sign and then like the same equation? I'm not understanding why you got the same equation.
What I was saying is someone had asked from a previous class, somebody had asked me about the organization of your terms. Mm-hmm. What is right and what's wrong. And so I was just saying that these are different ways that you could express this final answer.
Oh, okay. So I'm looking at it like, did I copy down something wrong?
No. Okay. Yeah, but you got when you said that while you writing did the same thing, then you got it. It's just basically different ways of writing the same thing.
Got it.
All right. Anything else before we do another one? All right, so for this next one, we have 16w to the 4th minus 40w to the 3rd minus 12w squared plus 30w. Once again, we have 4 terms. So we want to factor by grouping. So when we do it, we want to be careful. We want to make sure that minus sign, that this minus sign right here is included inside of the parentheses. You don't want to separate that 12 from the minus sign. In other words, you don't want to do this when you do your grouping. That's going to be create a totally different expression. So whatever's negative needs to stay negative. Whatever's positive needs to stay positive. So that's why that minus sign is in the parentheses with the 12. So be careful with that. Any problems with the grouping? So next, we're going to factor out the GCF. And when we look at this first one,
I have a question. Since there's not a common denominator for the 30, we just carry that over. There's no common factors for 30.
Well, we haven't gotten there yet.
Oh, okay. Slow down. I'm sorry.
So all we done at this point was just group, the first 2 and the second 2 together.
Okay.
So now we're looking at the common factors. And so we're looking at the common factors of 16w to the 4th minus 40w cubed. And so that is going to be 8w cubed. I can pull out 8w cubed from both terms.
Well, where'd you get the 8w cubed from anyway?
So once you got to analyze both of these with respect to each other and say, okay, when I look at 16, when I look at 16 and 40, what do they have in common? Where 16 is 2 times 8. 40 is 5 times 8. So I know they have an 8 that's in common.
Okay, got it.
Mm-hmm.
All right. I was trying to figure out where you got the 8 from.
Mm-hmm.
So we start with the 8W squared. Okay.
All right. And since one has 4 W's, the other one has 3 W's, so the most you can pull out is the 3 W's.
Right.
So that will leave you with 2W minus 5. Now the next one, that's 2 times 6, 5 times 6. So I can pull 6 out to the front. And if I pull out, notice I have 2 W's here, 1 W here. So the most I can factor out is the 1 W. So that's why we have 6W right here.
Say that again.
Well, we have 2 W's here and 1 W here.
Mm-hmm.
So the most you can pull out of each is the 1 W.
And it will still have a W left over to go inside the equation, right?
Mm-hmm.
Okay. All right.
So I pulled the negative out as well, but I'm going to act like I didn't because I wanted you to see what would happen. So if all I did was pull out 6W, not negative 6W, but just 6W, I would be left with negative 2W plus 5, right? But what I need is for both of these parentheses to be the same. Remember, that's what happened up here. I had x plus 4. That was the same. That allowed me to move further in the process.
Okay.
So I need both of these to be the same as well.
So that would make it wrong. That would make that wrong.
Right. Or it stops me from going further.
Okay.
Mm-hmm. So what I would do is not just factor out 6W, but factor out negative 6W. Because remember when we talked about pulling the negative out before, that changes each one of these signs. So if I pull out negative 6W, now I'm left with 2W minus 5, which is important because that's exactly what I have right here. So that's why we had to pull out the negative 6 instead of just pulling out positive 6. All right, make sure we're okay. Once again, you always want to give yourself a chance to digest this stuff. You hit in the face with it for the first time in a long time or the first time period. So you do want to give yourself a chance to practice this stuff out before I don't want you to get discouraged, in other words. So we pulled the 2W minus 5 out front. And then what's left is the 8W cubed minus 6W. All right, so now before we go to what I mentioned after that, questions on what we did.
This damn thing. Oh my God.
All right, so to finish it off, you're back, so we can go ahead. All right, so to finish it off, when I look at this last set of parentheses, notice that both of them are even numbers, so I can factor out a 2. I have an 8 and a 6 there. And also I have a W that can be pulled out of each one of these. So notice in the red, I said always check, or maybe I should say recheck your groupings for GCFs. So since I can pull 2 W's from each one of these terms, I do so, and that leaves me with 4W squared minus 3. Because I pulled 2 and 1 W out of each one of these terms right here. So one thing we're going to lean on moving forward is to always look for the GCF first, because we actually could have pulled that 2W out right here. So notice all of them are even, all of them have a W. We actually could have pulled the 2W out first, and we wouldn't have to worry about it at the end. And that's what we're going to focus on moving forward. Always look to pull out the factor out the GCF first.
Okay. I think I got a little confused. Can you say that? I'm not understanding that part.
Well, right here, when you look at those two numbers, or two terms, there was a 2W that was in common. You know, when you look at 8, that's 2 times 4.
Right.
6 is 2 times 3.
Right. Mm-hmm.
And then each one of them had a W.
Okay.
Is that a question?
I don't know. I just might need to do this a little bit more because that part is right there. It's confused me.
Well, let's see. If you had 8W squared minus 6W, right?
Mm-hmm.
You see both of them have 2 that's in common, so we can pull the 2 to the front. And how many W's can
2.
we pull out of both?
1.
Uh-huh. So what's left out of this term right here?
4.
4W.
W and then 3W, right?
Well, just 3. Because
just 3.
Yeah, because we got that 1 right here. All right. So you cool with that, right?
No, because I'm confused. Why doesn't the 3 have a W2?
Now, don't forget, when you go back and multiply, this represents multiplication, right? So when I multiply this back out, that's where the W is going to be at.
Oh, okay. I think I need to do that a little bit more because it's kind of confusing to me.
Yeah, just getting used to the process. Yeah, because see, that W is represented, this W and this W is the same W. So 2W times 3 will give me 6W.
Okay. Mm-hmm. All right. I got it. Thank you.
Yep. And so, and that's all that was right here, is just emphasizing that part of the process. Let me see, 6W, yep. All right. So I'm going to erase that. And that's all we did right here was we took that 2W out of here. And normally you put the 2W in front, all the way in front. And so going back here, if I had done this the way we're going to do it in the future, I could have pulled 2W out of all 4 of these terms and wouldn't have to do it at the end. And so that's how we're going to moving forward. We're going to make sure we pull the GCF out first so we don't have to do it in the end. All right. Any questions?
Is the final answer the one in the purple box?
Yep, right here. Yep. All right. Questions? Any questions? So make sure you try this stuff out. See if you get stuck on any. Like I said, some of the stuff is going to resonate better with you after you start practicing it out yourself. Especially, like I said, if you haven't seen it in a while, you got to get back into practice and get back into thought process of factoring out your GCFs and factoring, period. All right. So before we close out, any more questions? Any questions? Make sure we're good. All right. So I'll see you guys on next class. We'll get more into factoring, do some more factoring. Of course, if you have any questions or you run across any type of factoring issues, and make sure you bring those to class so we can factor them out and talk about the process. All right. So I'll see you guys on next class, and have a good one.
Yeah, Professor, I need to talk to you about something right quick before
I'm gone. Hold on, let me, is it math related? Do I need to stop the recording?
Yeah, please.
Yep. All right. So let me do that.